action for performance and parameter settings during algorithm training process. The last part, I will share with you some successful case across different industries with our deep learning algorithms. So let's get started from the first part. So this slide provides an overview of the algorithm types supported by our different series of smart camera. For example, the SC2000E series smart camera only supports the deep learning OCR algorithm. The SC3000 smart camera, it is our universal series smart camera. So the almost deep learning algorithm available for SC3000, except for image segmentation, image retrieval, instant segmentation, and supervised segmentation are not available for SC3000 smart camera. Well, the Vision Master software, it is our algorithm platform. So all of the algorithms are available for Vision Master software. But by the way, if you want to use the deep learning algorithm, you need to purchase a full function dongle, and then all of the deep learning algorithm can run it on Vision Master software. Here, there are some important notice. Except the deep learning correlating algorithm, other algorithms require model training based on actual samples. Since the correlating algorithm doesn't support local training because the algorithm is supported by Hikrobot, we have powerful sample database, so we can continue to optimize the algorithm and to upgrade the performance and the accuracy. So if the performance of the correlating algorithm cannot meet your requirement or recognition rate is not satisfactory from your side, of course, you can always feedback your sample pictures or your background information to us, and we can do the customization, the algorithm based on your actual sample image and background information. On this page, the main focus is to explain the meaning of algorithm type and applications for these different algorithms are suitable. The first algorithm is image segmentation. The image segmentation algorithms are typically used for pixel-level hyperspin detection, such as identifying scratches, stain, and other defects. By integrating a block analysis modular, those defects can be clearly visualized in the render image. The second algorithm is character training. It means OCR functions. It is used for character recognition and positions. It is divided into two separate algorithms. One is single character recognition. Second one is text line recognition, and then to predict the positions of the text line in the image. The third algorithm is image classification. The image classification algorithms are used to categorize entire image, are typically suitable for sorting products with significant difference. Example includes package sorting in logistics industry and packaging recognition in the food processing industry. The first one algorithm is target detection. It used to judge the category of object in the image and give the location information. So maybe from now, you may be confused what the difference between the deep learning image classification and target detection. The image classification distinguishes category at the entire image level. So it's typically used for broad classification, such as telling apart an apple from banana as shown in the figure. On the other hand, the target detection algorithm locate and identify targets within an image, mainly distinguish subterms such as different types of the screw. So if you are a test, you want to recognize the screw type, maybe type 1, type 2, type 3, etc. But for your sample pictures, there are a lot of multiple screws in the image. So in this case, the target detection algorithms are more suitable because the target detection algorithm can not only to recognize the type of the object, but also can give you the predict the position information in the image. So this is why the target detection algorithms are more suitable for recognition subterms category. The next one algorithm is image retrieval. The image retrieval is the intended model from image classification. So it is also used for set classified category, but it is very high efficiency, a high processing pixel level algorithm. So they can search for image with similar characteristics to the input image in the specific image dataset. The next one, instance segmentation. The algorithm judge the object category and predict its pointer position. So it's not only the high-precision pixel level algorithm, but also distinguish different instances on the image. So this algorithm is more suitable for sample with specific counters, where tab can be shorted based on counter variations. The last one, algorithm, it is unsupervised segmentation. The term unsupervised refers to the fact that we cannot forecast the type or location of defects. Instead, the algorithm learning from the OK samples and then predict the potential of detection location based on the OK samples. So the unsupervised segmentation algorithm, it means we only train the OK samples, and then the generated algorithm can predict the defect in the image. So they are all the algorithm categories that Hikrobot can offer. So in the next part, let me briefly walk you through the training producer for all of the algorithms. If you need to train a deep learning algorithm, a separate software is required. The software named Vision Train. You can directly download the software from our official website. There are 5 steps for the training algorithm. The first step, we need to select the training tab. It means you need to select which kind of algorithm you want to use in your project. About the selection of the algorithm tool, you can refer to previous page to find the most suitable algorithm for your test. The second step, we need to do the sample labeling. So in the next part, I will introduce the sample labeling in details. The third step, we need to configure the corresponding parameters such as the purpose of training the algorithm for the camera. So we need to select which kind of serial smart camera we want to use with the algorithm, and to setting some file storage type, some training path size, etc. After the training is complete, we will obtain the algorithm model and generated labeled data file. Since the Vision Train is Windows-based software, where our smart camera are developed on Windows Linux system. So the algorithm generated by Vision Train software cannot directly use for smart camera. So we have to do the convert algorithm model for the smart camera. But however, if the algorithm that you train the model is intended to run on Vision Master software, the model generated by Vision Train can directly use in Vision Master, because Vision Master is also based on Windows system. This model conversion is a necessary step for smart camera. So on this slide, I present the 2 methods for model conversion. The first approach involves the online AI training platform. The second solution is to install the offline conversion tool. If you are more interested in the second option, you can refer to our online tutorial video. In this video, provides a detailed walkthrough of installation and conversion process. If you are unsure how to perform the model conversion using the online training platform, we can have a look at the following video. This video demonstrates the step for model conversion using online training platform. If you don't have an account on the platform, you can register using your email address. It's for free. On the platform, you need to upload the algorithm model that generated by Vision Tree and upload the compressed file. In this file, it should be include the sample pictures and label data file. And then the AI platform will automatically convert the algorithm model for your target smart camera. During the model training process, there are certain requirements for graphic card. The sample image. This page primarily introduces example of training requirement and compatible graphic card model. The first requirement, if you want to train a deep learning algorithm, you need to prepare a graphic card with 6 GB memory. Therefore, if there are too many types of defects, it may require more than 6 GB memory of the graphic card. To train a model, you need to ensure that there are at least 11 sample pictures labeled. Of course, the more sample you train and the greater efficiency of the algorithm. The third requirement is a recommendation that we recommend that the defect size should be more than 4 pixels. If the defect occupies fewer than 4 pixels in the image, we need to consider changing the higher resolutions camera to acquire image to improve the defect pixel size. The next requirement, it is a limitation from Vision Tree. On the Vision Tree, you can create 32 labels. So the 32 pieces labels available, you can create it in Vision Tree software. The last requirement, it is for resolution limitation for sample pictures. The maximum resolution supported is 20,000 times 20,000 pixels. The minimum resolution required to more than 32 times 32. The follow table is show the compatible graphic card with our Vision Tree software. The current Vision Tree software supports 40 series graphic card. Since the 450 series just be related, so we are also actively working on compatibility development with the 50 series graphic card, and we will provide the compatible version Vision Tree in the next quarter. So the next part, I will clarify some key considerations for labeling during the training processing. When we to market the detection defect region, we can using the polygon and rectangle tools. So there are some requirements for this process. The first, we need to perform the pixel level labeling. Don't combine the agent defect into a single region. The second requirement is for defect size. If the defect is extremely small size, in this case, the label may be drawn a little bit thinner. But on the other hand, if the defect is very obviously, it occupies very large size, pixel size. In this case, we need to ensure the label area close match the actual defect size. So all of the three requirements are very important points. They can directly affect the efficiency and accuracy of the algorithm. So when we do the sample labeling, we need to pay more attention for this point. On the following part, I also show some labeling case from different algorithms too. The left side, there are labeling case from image segmentation. So this is the origin pictures. There are arrow example and character example. So in this case, we can share with you when we do the sample labeling, we need to pixel by pixel mark it. and agent defect array cannot be directly drawn into one block. The right side labeling case for OCR recognition. In the middle, it is also incorrect sample because the detection box, the rectangle box, is too large than the actual text line. The right sample pictures is also wrong example because the direction of the rectangle box, the RI region, is not consistent with the direction of the text line. So please have a look for the following requirement for rectangle box during the labeling for OCR algorithm. The first, the direction of the rectangular box should be consistent with the direction of the text line, like this correct example. The second one, the size should be marked that the upper and lower edge don't adhere to the character. And the last requirement, when we draw the detection region, when we draw the OCR text line, we need to reserve a little bit space at the left side and the right side. The reserved space size should be half of characters. So like that correct example. So when we train OCR algorithm, we can always to have a look to refer to the correct example because it is perfect example to show you how to do the sample labelings for the OCR algorithm training. The next labeling case is for object detection. So during the labeling process, we cannot miss any detection target. So if we pay more attention to see this arrow example, we will see not only one object should be detected in these samples, there are multiple objects in the image. So in this case, we need to make sure all objects in the image are marked because any missed object will mark it as a background during the training processing, so it will be directly affect the algorithm accuracy. So for this case, we also put a correct case in here. Why? Because sometimes from the sample pictures, sometimes there are multiple objects in one picture, in one sample image. So sometimes the multiple objects are stick with each other, are overlapped. So in this case, we can just draw the detection array detection box with the overlap with the stick is acceptable. So it means if there are overlap between the multiple targets during labeling, we just bounding the box can be staked based on actual distribution of the object. So our algorithm can permit the staked object detection box with each other with the overlap. Our algorithm can acceptable this situation. The last one, labeling case for unsupervised segmentation. Since the unsupervised segmentation algorithm will only train the OK samples, so the traditional method will just import the pictures and mark it as the OK samples and then repeat to do it. And the sixth method, or we can just do it with in batch. So it means we can load an active folder and then add a folder button to directly import the pictures in batch. And then the vision train software will automatically mark all of the pictures, all of the samples in as the OK. So it is more efficient way. It will take more smaller time to do the calibration. The last part, it is some successful case across different industry with our deep learning algorithm. The first application case for image segmentation in consumer electronic industrial for quality control of mobile phone. In the mobile phone modular components manufacturing, there have requirement for quality control. So the image segmentation algorithms are important to detect various types of defects in components to make sure defective products are rejected and only qualified products are enter the market. So for this project, there are a lot of difficulty. For example, the complex and diverse defect, and there are a random degree of the defect, and there are some reflective on the surface of objective, and there are some interference from backgrounds. Even though all of the difficulty happens from the project, from the system, we can also successfully deliver our vision system for this project, for this mobile phone components manufacturing with the high detection accuracy. The detection accuracy up to 99.53%. The number of misdetection is 0. The number of false detection only occupies 0.47%. The second application case with the target detection algorithm in pharmaceutical industry to recognize the medical box and to counter the quantity of the medical box, each of them. Pharmaceutical manufacturing may experience product loss inside equipment due to some reasons such as manufacturing processing, equipment vibration, and other variables. So in this case, we evolved target detection algorithm to recognize the type of medical boxes and to counter the quantities of medical box. There also have some challenge, for example, the overlapping between medical boxes and the random degree and positions of the medical box on the conveyor. And the second challenge is from our end user. We need to make sure the detection accuracy should be 100%. So all of the requirement challenge we can handle using our deep learning target detection algorithm. So I can see for the target detection algorithm, we have a lot of the application case, a lot of successful case in different industry, different application, and different scenario. So the target detection algorithm, it is very mature vision solutions in machine vision industry. So if you never try our deep learning algorithm, so I can say that the target detection algorithm is the good choice for you to test our deep learning algorithm because it is very easy to train algorithm model. It's easy to acquire the target sample pictures, and then you can to have a look about our deep learning algorithm performance and accuracy. You can start from the target detection algorithm if you never try our deep learning algorithm. The last one application case is for OCR recognition in semiconductor industry to recognize OCR in wafer. A wafer refers to a silicon chip used in production of silicon semiconductor integrated circuit. So this project is for character recognition on different types of wafer. So from the right pictures, right videos, you can see that the characters in the semiconductor industry totally different from traditional OCR. So the traditional OCR algorithm cannot be used to properly recognize those characters. So this is why we specifically developed a dedicated semi-OCR algorithm model for this project. We totally trained 1,400 pieces samples and then generated algorithm model directly used in real project, in actual project, the detection accuracy up to 99.95%. The algorithm time consuming only occupied 40 microseconds. So from this test data, we can see the OCR recognition algorithm. We can not only offer a high performance, but also high accuracy algorithms. So that concludes today's webinar. If you have any questions about contents, please feel free to post them in the chat box and we can answer the questions one by one.